Welcome to the Space Telescope Public Lecture Series. Tonight, Astronomy versus Astrology. What's the difference really? With Nicole Arulanantham. I'm your host, Dr. Frank Summers of the Space Telescope Science Institute, and I want to thank our wonderful tech team that brings this to you live over the internet, Thomas Marufu and Grant Justice. In our upcoming talks, we only have one scheduled right now, but don't worry, I will get the other one scheduled. It's just that, during summer break is a hard time to get people scheduled. So we have for you Todd Lauer of NSF's Noir Lab. That sounds really cool, but it's the National Optical and Infrared Laboratory. And he'll be talking about an amazing discovery on how dark is space. What is the depth that you can go to and really see the faintest, darkest things there are? Well, you got to measure it not from where we are in the solar system, but at the edge of the solar system. It's a really cool measurement, and he'll tell you about that in October. In November and December, we will have an amazing speaker for you that I promise I will get scheduled this month. When I do have them scheduled, you can find them here at www.STScI.edu/public-lectures, or if you just put in Space Telescope Public Lecture Series in your favorite search engine, you'll come up with this page. And on the left side of this page, you can see that we have our link to our webcast, both our YouTube playlist and our webcast archive at the Space Telescope Science Institute. On the right-hand side, you can see the email subscription box. Just enter your email address, hit subscribe, and you'll get our monthly emails. Also on that webpage, you will find a list of all the upcoming lectures. And if you read more about each of the lectures, you will find the speaker and title, you will find the abstract about it, and after it has happened, you'll see the links to the STScI webcast as well as the YouTube webcast. For email announcements, well, I've already told you the easiest thing to do is just sign up at our website. You can also subscribe to our YouTube channel, youtube.com/all one word Hubble Space Telescope. All right, that will find you all of our videos. And if you hit the subscribe button, you will get the new video notices and reminders of our live events. Finally, if you have comments or questions, you can send them to the email address publiclecture@stsci.edu. On social media, you can find our institute for the Hubble Space Telescope, for the upcoming James Webb Space Telescope, and for the Space Telescope Science Institute on Facebook, Twitter, YouTube, and Instagram at the addresses provided here. Myself, I do a tiny bit of social media, and you can find me as Dr. Frank Summers on both Facebook and Twitter. And now our news from the universe for September 2021. Our first story, celebrity breakups, comet style. Now, if you pay attention to the gossip magazines, you hear a lot about celebrity breakups, and they seem to go, they break up and they get back together and they break up, and it seems to go on forever. Well, I got to tell you, they got nothing on comets, okay? And so let's talk about comet breakups. And this is Comet Atlas, and it's in the middle of a severe breakup. Matter of fact, it's disintegrating and going to pieces, all right? This was as Hubble observed it on April 23rd, 2020. And you might say, okay, yeah, the comet is broken up, and that's the big story, that the comet breaks into all these pieces and the pieces disintegrate. But there's a lot more to this story. You see, because Comet Atlas, when it was discovered, was found to have the same orbital trajectory as the Great Comet of 1844. Now, I also have to tell you, I'm lying to you with this picture. This picture is actually of the Great Comet of 1843 because I couldn't find a picture of the Great Comet of 1844. Turns out there was Great Comets in 2 years in a row. They had a really good run in the 1840s. All right, and so the two comets have the same orbit, and they did the mathematics and they pulled it back and they said, well, what probably happened? So this is a much larger story of the breakup, and it starts 5,000 years ago. So around 5,000 years ago, a comet passed by the sun. And you can see this little comet doohickey that I've drawn here on the left-hand side of the screen. And after it passed by the sun, the comet broke into two pieces, two relatively large pieces. And those pieces had just a slightly velocity kick, okay? One was moving just a tiny bit slower than the other. When it broke apart, and over the 5,000 years that it was orbiting, these pieces slowly drifted apart. They stayed on basically the same orbit, but they pulled up further and further apart. The first piece, the bigger piece, arrived in 1844 as the Great Comet of 1844. The second piece didn't arrive till almost 200 years later in 2020 as Comet Atlas. And as that piece arrived, this is the one that disintegrated and didn't. So you may think that the celebrity breakups take forever, but this one shows you that comet breakups can actually last 5,000 years. Scientifically, what do we learn about this? Well, we really, when the comet breaks up, you actually expose the interior of the comet. And so the question is the interior of the comet a uniform structure, or is it lumpy? And if it's lumpy, on what scale is it lumpy? All right, and so you study questions like how many fragments of comets did it break into? What is the size distribution of the fragments, from the tiny pieces to the very large pieces? And how far from the sun do these fragments disintegrate? How much solar radiation is necessary to cause them to break apart? And furthermore, how long do fragments take to disintegrate? What is the density structure of these fragments? Do they disintegrate quickly? Do they disintegrate slowly? And in particular, if you have two fragments of the same size, do they both disintegrate in the same amount of time? So the astronomers have been studying this. Here are two images of Comet Atlas's breakup. And their conclusion based on Comet Atlas is that even very small comets can have lumpy interiors. They suspect the parent body for this was less than 1 kilometer across. And so even comets as small as 1 kilometer across can have lumpy interiors. And that's what we can learn from the breakup of comets. Our second story, NGC 2276, you're pulling my arm. Now, this is, of course, a variation on the phrase, you're pulling my leg. But galaxies don't have legs. They do, however, have arms, especially when they are a spiral galaxy. These are three gorgeous spiral galaxies, NGC 1232, the Whirlpool Galaxy, and NGC 3982. And one of the things that you see is the beautiful symmetry of these spiral arms that makes these spiral galaxies just so gorgeous. Well, a recent observation from Hubble looked at a spiral galaxy called NGC 2276. And here you see those beautiful spiral arms, but you also see a bit of asymmetry. There's something not quite even. The pattern isn't smooth around it. So what's going on? Well, to answer that, let's look on a larger scale. This is an image from Adam Block, and you can see that NGC 2276 is nearby galaxy NGC 2300. And the gravity of NGC 2300 is pulling on NGC 2276, and it's pulling stronger on the near side than it is on the far side, producing a pull on the spiral arm on the near side of 2276. And this image also includes hydrogen alpha, which shows you where the star forming regions are. And you'll notice in the upper left of NGC 2276, there's enhanced star formation. There's a lot of star formation happening. And really that shouldn't happen in just one part of the galaxy. It should happen relatively all over when you have a star forming galaxy. So this indicates that perhaps the galaxy is running through an intergalactic medium, and that there is pressure pushing on these stars to create star formation. So the asymmetry in NGC 2276 on the right-hand side is caused by the gravitational tidal pull of NGC 2300, and on the left-hand side, perhaps by ram pressure compression as it's moving through this intergalactic medium. You'll notice I put a question mark there because it's not really proven that it is ram pressure compression, but it looks like one of the good explanations for it now, and people will, of course, study it more in order to figure out if that's true. But this is a galaxy where, hey, it's not lying to you. It's not pulling your leg, but another galaxy is pulling on its arm. Our speaker tonight is Nicole Arulanantham, and she will be talking on astronomy versus astrology. Now, Nicole is relatively new at the Space Telescope Science Institute. She's only been there for 1 year, which gives her a special distinction of she's been working at Space Telescope and she's never had an office at Space Telescope because we've been in work from home for the past year. Before she came to Space Telescope, she did her PhD at the University of Colorado Boulder, which is CU Boulder. She corrected me, even though you would think it would be UC Boulder. And she will not be talking on her thesis subject, but she works on protoplanetary disks. Before that, she did her master's at Wesleyan and her undergraduate work at UCLA. Nicole, in her spare time, likes to run, and she has joined a local group called A Tribe Called Run. So, ladies and gentlemen, please welcome Nicole Arulanantham.
Thank you, Frank. Can you see and hear me okay?
Yes.
Okay, awesome. So thank you all so much for joining. I'm really thrilled to be here and giving you the public lecture tonight. So as you can see on this title slide, our main question tonight is going to be understanding what the difference is really between astronomy and astrology. Now, if we were able to have this lecture in person, I would maybe ask for some audience participation at this point. So I might take a quick poll and ask everyone in the audience to raise their hands if they feel confident that they can answer this question right now. So without hearing the rest of the talk, I would ask who feels like they can tell me the difference between astronomy and astrology. And if we had a really engaged audience, we might see a lot of hands go up all across the room. So I would maybe pick on a few people who looked particularly confident, and I would ask them to tell us in maybe 2 or 3 sentences what the difference is between astronomy and astrology. Now, maybe we would have some rock star participants in the audience who could give us a perfect, beautiful answer. That would be really embarrassing for me because then I still have to give this talk, which is maybe pointless if somebody can already answer it. But I think what would more likely happen would be that people would be really good at describing astronomy or really good at describing astrology. And I think we would have a really hard time comparing the two without using language like nonsense or rocket science. So that's what we're really going to dive into tonight. Now, you may be asking yourselves, why is she so confident that this is a hard question to answer? Well, the confusion between astronomy and astrology is really prevalent in our society. And a couple of years ago, there was a really perfect case study that demonstrated this confusion. So I am personally a huge fan of the Bachelor and Bachelorette TV shows, but I hadn't really thought too much about the Australian edition of The Bachelor until 2019, when the show cast an astrophysicist, Dr. Matt Agnew, as the Bachelor. Now, Matt was going to be introduced to a whole group of single women, and he would get to go on dates with them over the course of the show. He would hand out roses to the ones that he really felt a connection with, and by the end of the show, he would have narrowed it down to his one true love. Lots of drama would ensue throughout the show, and we would be left with a beautiful happily ever after. Now, the reason that the Australian edition of the show came across my radar was because they released what was a very controversial promotional video. So in the video, we see one of the women, Abby, come up to Matt to introduce herself, and she says hello and then asks, "What do you do?" To which Matt replies, "Oh, I'm an astrophysicist." Then we have a slight pause, to which Abby replies, "Okay, I'm a Gemini." And then all of a sudden the music changes, it gets very dramatic. We can tell that Abby has made a huge blunder here because we see Matt looking flabbergasted. He takes a very long time to respond. So it's clear that something has gone wrong in this interaction. Abby has made a mistake. Now, then the music changes again. It becomes a little bit more bubbly and fun. And we see some clips of the women talking inside the house after they've introduced themselves to the bachelor. So we hear somebody say that it sounds like a fake job, like my boyfriend's an astrophysicist. Off camera, we hear a producer ask another contestant whether she understands what Matt's job is, to which she replies, "No, not really, am I supposed to?" And to answer her question, not necessarily, right? We don't all need to know everything about everyone that we might meet. But it's worth noting that these women were absolutely skewered on social media. Now, I'm going to give you a little bit of behind the scenes information that came out in interviews after the show aired. Our lovely Gemini, Abby, and the Bachelor, Matt, both shared that their conversation where Abby said that she was a Gemini went very differently in real life, and that the producers of the show had actually pieced together clips of what she had said to make it look like she had responded that she was a Gemini when Matt told her that she was an astrophysicist. So this is very interesting for a couple of reasons. So first of all, if Abby really had gotten confused, that's something that's really prevalent in society, so she's not out of the ordinary here. But if this was true, that the producers of the show had cut and pasted these clips to make it look like she had gotten confused, it's clearly done in a way to make us feel some type of way about the contestants that might influence our perception of them moving forward and watching the rest of the show. And so it's clear that not only is this confusion prevalent, people know that this confusion is prevalent and are very much inclined to use it as a way to entertain rather than correcting some of the misconceptions or answering some of the very reasonable questions that the women were asking in the promotional video. Now, it was clear from watching the video that we were supposed to think a certain type of way about the intelligence of these women. And so, in the interest of working smarter and not harder, before we really dive into the talk, we can see whether an etymology lesson will clear things up. So we'll break down the words into their components and see if we can get some definitions out of that maybe these women should have been able to figure out. So we'll start with our prefix, astro, which is common to astronomy, astrophysics, and astrology. And we know that the prefix astro tells us that something is related to stars, celestial bodies, and outer space. Then we'll take a look at our suffixes. So the suffix onomy tells us about a system of rules, laws, or knowledge about a particular field. The suffix physics tells us about nature or natural order. And finally, the suffix ology tells us about a field of study or a discipline. So we have our breakdown, we know what our prefix means, and we know what our three suffixes mean. So let's stick them all together and see if we can get some meaning out of these words. So when we do this, we'll find that astronomy is a system of rules, laws, or knowledge about stars, celestial bodies, and outer space. Astrophysics tells us about the nature or natural order of stars, celestial bodies, and outer space. And finally, astrology tells us about the field of study related to stars, celestial bodies, and outer space. So I've kind of spoiled the punchline here a little bit with the title of this slide, but it's clear from these definitions that etymology can't help us here, right? If we happen to be a contestant on the Australian version of The Bachelor in 2019, we would not be able to spout out these definitions and provide any meaningful information for the people who are confused about what an astrophysicist might do or about what the difference is between these three words. So maybe it's not really fair to expect people to already know what the difference is between astronomy and astrophysics and astrology. Now, we can learn a little bit more about why this confusion exists by taking another bit of a dive into social media. So if we go to the wildly popular video sharing app, TikTok, we can do a quick little thought experiment. Now, I personally had to get rid of TikTok off my phone at the beginning of the pandemic because all of a sudden it would be 2 o'clock in the morning and I'm still scrolling through videos. But if any of you wanted to open up the app and search for a video on astrology, you could search for videos that were tagged with this hashtag, and that would tell you that the video mentioned something about astrology. So when we do this, we get a whole list of some of the more popular videos, and we can see that all of the videos that are tagged as astrology have a total of 24.2 billion views. Now this is a lot. This is a really big number. And just for context, there are just under 8 billion people in the world today. So if these astrology videos have been viewed 24 billion times, that means that's enough views for every single living person to have viewed 3 videos on astrology. And now, of course, we know that not every single person in the world is going to be on TikTok looking at astrology videos, but this just gives us some context about how popular and widespread this information about astrology is. Now, if we do the same thought experiment, but instead of looking for videos tagged with astrology, but look for videos tagged with astronomy or astrophysics, we see that these videos have been viewed a combined total of only 540 million times. Now, this is still a pretty big number, but it's certainly not 24 billion. So just for context again, a total of 540 million views would mean that there has been 1 video viewed for every 15 living people. So this kind of gives us a sense that astrology is maybe a little bit more accessible to most people across the globe, and that astronomy and astrophysics may still be a little bit hidden. And this is something that we as astronomers and astrophysicists at the Space Telescope Science Institute are actively thinking about, is how we can make our work that we do here more accessible to everybody. And it's something that maybe all of you, after listening to this talk, can think about doing moving forward as well. So we've seen that maybe talking about the difference between astrology, astronomy, and astrophysics can get a little bit confusing, right? The words sound very similar. So instead, for the rest of the talk, we'll reframe our question. So instead, we'll think about astronomers and astrophysicists versus astrologers, and we'll try to answer the question of what they all do, really. So we'll proceed to answer this question with 4 steps. We'll start by going through a brief history of humans studying patterns in the night sky. We'll talk about how then work transitioned to figuring out how celestial bodies move over time. We'll talk about the divergence that we see in modern astronomy and astrophysics and astrology. And finally, I'll leave you with some more ways to explore the differences on your own that you can also feel free to share with other people as well. But first, we'll dive into our brief history. So for as long as humans have lived on Earth, we have archaeological records of people looking up at the sky and identifying patterns. Now this map of the world shows a red pin everywhere that we have really clear archaeological records of astronomical observations. So if people taking pictures, drawing pictures and taking note of what they saw in the night sky. And we can see that this work really spanned the entire globe. Everyone who could possibly be looking up was doing so. And we have some really neat evidence of this. So for example, here on this slide, we're looking at a slab that is currently on display at the British Museum. And this slab was discovered in what is currently the Middle East. And it dates back to Babylonian times, so about 2,000 years ago. And the markings on this slab are actually a lunar eclipse table. So this tells us that people in Babylonian times were monitoring the lunar eclipses, and they were making predictions about when those eclipses would occur again. And this type of record, again, is found all over the globe. So the earliest eclipse records date back to 4,000 to 4,500 years ago. People have been doing this for a really long time. Now, in today's world of astronomy and astrophysics, the International Astronomical Union recognizes a total of 88 constellations, or 88 patterns in the sky. And these are taken from Greek and Islamic astronomers. Now, these 88 constellations that we recognize include the zodiac constellations. So these, you may recognize the names of some of these. We have Scorpius, Libra, Virgo, Leo, Cancer, Gemini, Taurus, Aries, Pisces, Aquarius, Capricornus, and Sagittarius. Now, these zodiac constellations are very interesting because at the time that they were identified and mapped out, people still thought that the sun actually traveled around the Earth, so that the Earth was the center of the universe and everything else orbited around it. And so from our vantage point on this stationary Earth, it looks as though the sun is taking a path across the night sky. Now we know now that Earth is actually rotating on its axis, so we're either facing towards the sun or away from it. But at the time, it looked like the sun was traveling across the sky, and it appeared to change position every sunrise with respect to these background zodiac constellations. And so these zodiac constellations played a really important role, and they acted as a good reference point. Now, I want to point out that we're looking at the Greek and Arabic constellations, and we'll focus on Scorpius for now. It turns out that not all civilizations across the globe that were tracking these patterns of stars in the sky interpreted the zodiac constellations in the same way. Now, some did. So, for example, astronomical records from the Aztecs show that they also believed that Scorpius was a pattern like a scorpion. But if we look at the constellations that were identified by Chinese astronomers, we can see that they had a much different interpretation. So Scorpius was actually two constellations that were part of a much larger pattern in the sky called the Azure Dragon. And the constellation Scorpius, one part made up the tail of the Azure Dragon, and the other part was described as a changing room or a temple within a mansion of the Azure Dragon. So we can see, and this is something that's important to remember, is that the patterns in these stars were interpreted very differently across the globe, despite the fact that now we recognize this one fixed system. So just something to keep in mind. But at the time, astronomy and astrology were really the same thing. And so people were able to use these zodiac constellations as well as lunar and solar eclipses as really useful references for the passage of time. And astronomers and astrologers had a really important role at this time because it was their job to make predictions about lunar and solar eclipses. And it was also their job to alert everyone to when, for example, the harvest season was coming, or when we could expect to have more consistent warm weather. And so in an agrarian society, this was really, really important information. Now, of course, there are stories of some ancient rulers using astrologers for more nefarious purposes. So for example, making predictions about when they should go to war, or when a ruler should be removed from the throne because they were abusing their power. And it was very treacherous back then because people would kill their astrologers if they made predictions that were wrong or unfavorable. But for a long, long time, this is what astronomy and astrology were. And some of the seasons are still celebrated at different times across the globe. So for example, Chinese New Year is still celebrated in February, at the beginning of February. And so this marks the time two lunar cycles after the 11th month of the year. So it falls in early February. My family is Sri Lankan, and so in April we celebrate the Tamil and Sinhalese New Year's. And so this marks the start of the harvest and planting season, and it is celebrated on the first new moon after the sun moves from rising in the constellation Pisces to rising in the constellation Aries. And finally, we're actually right in the middle of Rosh Hashanah, or the Jewish New Year, which is celebrated at the beginning of September. And so our seasons and our celebrations are very much marked by the transition of sunrise through these different constellations. So this is our history, right? This is how humans first started to study these patterns in the sky. But of course, we always want to know more, and the universe is always changing and doing something new. And so new information started to come to light that helped people get a better sense of how celestial bodies move over time. Now, heading into the 1500s, Copernicus started to work out the details of what we now call the heliocentric model. So remember, prior to this work, people believed that the Earth was the center of the universe and the sun orbited around the Earth and everything else moved around the Earth. But Copernicus and another philosopher long before him thought about this as well independently. Copernicus formulated our model that we now know to be correct, where we have the sun at the center of the solar system and the Earth and all the other planets orbit around it. Now, this was controversial at the time because it went against the grain of what people had believed for a very long time. And so Copernicus was naturally very hesitant to publish. But he received a letter from the Cardinal of Capua, and I'm showing a translated clip here. We'll read through it. And the Cardinal wrote to Copernicus and said, "Some years ago, word reached me concerning your proficiency, of which everybody constantly spoke. At that time, I began to have a very high regard for you, and also to congratulate our contemporaries among whom you enjoyed such great prestige. For I had learned that you had not merely mastered the discoveries of the ancient astronomers uncommonly well, but had also formulated a new cosmology. In it, you maintain that the Earth moves, that the sun occupies the lowest and thus the central place in the universe, that the eighth heaven remained perpetually motionless and fixed, and that together with the elements included in its sphere, the moon, situated between the heavens of Mars and Venus, revolves around the sun in the period of a year." And he goes on to give Copernicus a little bit more flattering and concludes by saying, "Therefore, with the utmost earnestness, I entreat you, most learned sir, unless I inconvenience you, to communicate this discovery of yours to scholars, and at the earliest possible moment to send me your writings on the sphere of the universe, together with whatever tables and whatever else you have that is relevant to this subject." And so people were very interested. There was a lot of interest in this idea of a heliocentric model of the universe. And we now know that, the sun is not the center of the universe, but this was really revolutionary thinking at the time that people were excited about. And so the wheels were starting to turn, that maybe the patterns of motion seen in the night sky were not quite what they were originally interpreted to be. Then we come to the year 1572, and the astronomer and astrologer Tycho Brahe identifies something very interesting in the sky. So he was looking at the constellation Cassiopeia and noticed in 1572 that all of a sudden a very bright new star, or nova, appeared in the sky. Now we're looking at this, we now know that this was a supernova. And when we point our X-ray telescopes at it, we see this beautiful remnant gas. And this is very hot ionized material that produces X-rays that we can collect at our telescopes here. But at the time, Tycho Brahe did not have an X-ray telescope. And so he just saw this bright spot. Now this was really remarkable because the bright spot was actually more comparable in brightness to the planets than it was to the background stars. And we saw that the cardinal mentioned something called the eighth heaven in his letter to Kepler. That was the term that was used at the time for the background stars that were much fainter than this new star that had appeared. And so the appearance of this bright star was very interesting because up until this point, people had thought that the eighth heaven, or those fixed background stars, didn't change, that they just remained constant and nothing new would ever happen. And so the appearance of this bright new star was really something remarkable. And other people were able to notice it too, but Tycho Brahe was really known for being a very careful recorder of observations. And so he was really the one who kind of pioneered the work on this new nova. Now, about 30 years later, another new star appeared in the night sky, and this time Kepler was the person to monitor it very carefully. Now, Kepler is not necessarily the person who first discovered this bright new star. A lot of other people had seen it as well. But Kepler played a very important role here because at the time, in 1604, he was working as a mathematician and astronomer and astrologer in service to the emperor. And so it was really important for him to provide some interpretation of what was happening in the skies, right? This was his job. He was very important. And here, of course, we are looking at a beautiful Hubble image of what is colloquially known as Kepler supernova. This was actually taken and put together by scientists here at Space Telescope. But at the time, again, this just looked like a bright star. Now, the appearance of this new star happened to come at a very interesting time because at the time, astronomers and astrologers were noticing that the planets Jupiter, Saturn, and Mars appeared very close together in the sky. And so this was known as a conjunction. And so Kepler's interpretation, which again has been translated here, was that the star significance is a difficult matter to establish, and we can be sure of only one thing, that either the star signifies nothing at all for mankind, or it signifies something of such exalted importance that it is beyond the grasp and understanding of any man. This star is so far above all the planets that from its position, according to the teaching of Copernicus, not only would the bodies of the planets be invisible, but even their whole orbital spheres would appear as small as very faint stars. Therefore, from all the astrologers can tell us, and from all we know about the great conjunction of Saturn, Jupiter, and Mars, we can deduce nothing at all about the flaring up of this star or about its substance. Now, this is a little bit of a confusing interpretation, so we're going to break it down a little bit. Now, because this new star was so bright, again, it was closer in brightness to the planets than the background stars, astrologers at the time were interpreting it as something that had been manifested by the planets. But Kepler was very clever. When he was looking at the motions of things in the sky through the night, he noticed that this new star actually didn't move. And so he realized that if it were really associated with the planets, it would maybe move faster through the night sky at the same speed that we see the planets and the moon moving over time. And so he thought that this bright new star was probably further away than the planets and the moon, which is why he says here, not only would the bodies of the planets be invisible, but even their whole orbital spheres would appear as small as very faint stars. So he built on the work of Copernicus and was able to do a little bit of interpretation of this new star in that heliocentric framework. Okay, so the pieces are very slowly starting to come together. People are starting to learn some new things about how objects move through the sky. And then in 1610, Galileo made a very interesting discovery. So Galileo pointed his telescope at Jupiter, and this picture that we're looking at here is actually taken from his observations log from the night that he was looking at Jupiter. So he made a lot of drawings, and he drew Jupiter at this pinwheel thing, that we see here. And when he first looked at Jupiter, he also noticed three much fainter points of light that were all in a row. And he noticed that as he monitored this system over the course of the night, the three fainter dots changed position. So for example, here they were all three in a row on the right-hand side of the planet. Then later there were two on one side of the planet and a third on the right-hand side, and so on. And eventually a fourth dot appeared. So we now know that these are the four biggest moons of Jupiter that Galileo had discovered, which is why we call them the Galilean moons. And this was extremely exciting. First of all, it's always very exciting to discover moons. That's a big deal. But it also really provided conclusive evidence that objects could orbit other things that were not the Earth. So if the moons could orbit Jupiter, then maybe everything didn't have to go around the Earth. And this provided some further support for Copernicus's idea of a heliocentric universe. Now, Jupiter's moons are still something that are one of my favorite things to observe in the night sky. There's a very dorky photo of me floating around somewhere on the internet looking at this manuscript because it's on display in the library at the University of Michigan. But when observing nights are able to start up again, you can look at Jupiter and you can see the dots for yourself. And if you come back, maybe an hour or 2 hours later, you can see how the dots change. And so you can, pretend to be Galileo and make some of these observations yourself. It's great fun. Okay, so the wheels are turning and people are starting to realize that maybe this idea of Copernicus's has some merit. And then finally, Newton came along and presented his law of universal gravitation that stated that everything in the universe was gravitationally bound. And so this meant that the planets were gravitationally bound to the sun, Jupiter's moons were gravitationally bound to Jupiter, and this is what caused the planets to travel around the sun. And this fit very nicely with Kepler's laws because Kepler had also discovered that the planets much closer to the sun would take less time to go all the way around it, while the planets further away would take more time. So the puzzle pieces really came together, and this is really where it became clear that astronomy and physics are very intricately linked. And so from this point, the field started to branch off. Astrology started to fall out of favor, and astronomy and physics were pursued more closely together. Now, I told you that we were going to talk about the divergence in modern astronomy and astrophysics and astrology because we're seeing that astrology still is something that appears in our modern lives today. And you'll also notice that when we come back to our original question, I asked this in present tense. So astronomers and astrophysicists versus astrologers, what do they all do, really? Not what did they all do? Now we can answer this question by thinking about some recent celestial events. And so, for example, we can pretend that we're Kepler, but many, many years later, and we can think about the great conjunction of Jupiter and Saturn. Now this was something that happened in December 2020, and this picture was taken from just down the road from us in Baltimore, in Luray, Virginia. And we can see this really bright spot in the image. This is the planet Jupiter, and the fainter spot is the planet Saturn. Now the great conjunction happened when it looked like Jupiter and Saturn were meeting in the sky. And everybody was really excited about it. I know all of my neighbors were out and about trying to figure out how to watch it. Unfortunately, here in Baltimore, it was really cloudy and rainy at the time of the conjunction, so I didn't get to see it in person, but it was really cool to see everybody's pictures. Now, in the weeks and months leading up to the conjunction, there were astrology headlines everywhere. And the astrologers were assigning importance to the conjunction itself and using it to predict human behavior. So for example, there were headlines declaring that the biggest astrological event of our lifetime would arrive on December 21st, and people were offering predictions about how this might impact somebody's career or love life or more. People were asking whether this was the age of Aquarius and trying to understand what it meant that the conjunction had shown up. And people were also making predictions about more large-scale things that might happen in society. So for example, this German astrologer, Randon Rosenbaum, said, "People are saying that this is the same alignment that happened when Jesus was born. I have been hoping for a second coming of Christ to polish off the end of the year, but living in the 21st century, I speculate this can look like an alien invasion." It's always been omen in astrology. And so we can see that these predictions varied pretty wildly. So the astrologers knew that the conjunction was coming, and then used it to make some predictions about what might happen to individual people and society as a whole. Now, astronomers and astrophysicists, like myself and like my colleagues at the Space Telescope Science Institute, don't assign meaning to the conjunction itself. Instead, we know from the work of Kepler and Newton that this alignment happens because the orbital paths of Jupiter and Saturn make it so that it looks like the planets are passing in front of each other, when in reality, Saturn is much farther away than Jupiter. And so it's an optical effect that it appears like the two planets are meeting in the night sky. But we're still very interested in Jupiter and Saturn. They're really interesting giant planets. And we're also very interested in looking at their moons. So for example, this is a really beautiful image that was taken this July by the Juno spacecraft. And this is a picture of Jupiter's moon Ganymede. So this is one of the Galilean moons that Galileo first noticed in his telescope. Now, this picture is much more detailed than what Galileo was able to draw. And this is because it was taken by the Juno spacecraft. Now, Juno was launched in 2011 and took 5 years to get to Jupiter. And it took this picture, again in July, in infrared light. And so we're essentially seeing the heat that's coming off of this icy moon. And astronomers and planetary scientists will be studying the surface of this icy moon and looking to see if they can understand how high energy particles impact both the structure and the composition of ice on the moon. So this is really interesting, neat science. Now, astronomers and astrophysicists are interested in Saturn's moon as well. And this image on the right here is an artist's depiction of Dragonfly. Now, Dragonfly is a mission that was selected to go to Saturn's moon, Titan. And it's going to fly through Titan's very thick atmosphere and explore the surface of Titan. Now, Dragonfly is actually going to be built right down the road from us at Hopkins Applied Physics Laboratory, so this will be very exciting. But it won't be launched until 2027, so it's something to look forward to, but we won't have the beautiful pictures and the data for a while, so this is something to look forward to in the longer term future. Now, you might be thinking to yourself, well, astrology seems more relevant to me personally. But it turns out that astronomy and astrophysics is very relevant to us personally. And the reason is that mapping the surfaces and atmospheres of Jupiter and Saturn's moons can provide really valuable information about where extraterrestrial life might be able to survive. And so if we delve into science fiction a little bit and think back to, again, December of this year, there was a great movie called The Midnight Sky that came out. And George Clooney plays an astrophysicist who is talking at the very beginning of the movie to another scientist who is exploring a habitable moon of Jupiter. Now, this is a fictional moon that in the movie was discovered by George Clooney's astrophysicist character. But we can imagine, that we wouldn't find a potentially habitable moon if we didn't go and search for it. And so this has some really interesting, again, longer term implications for our lives as humans on Earth. And this information is stuff that can be applied to our study of planets that orbit around other stars. So as of the end of August, scientists had confirmed about 4,500 planets orbiting around other stars. So this is really, really exciting. And with the launch of the James Webb Space Telescope coming up soon, we'll really be able to take our characterization of these planets to a whole nother level. We'll be able to look at their atmospheres much more carefully to understand the composition. And unfortunately, it's much harder to take pictures of the surface of a planet around another star, right? This is something that we don't really have the capability to do yet. And so our work studying the moons of Saturn and Jupiter is going to be really valuable because it's work that might be able to be extended to studies of planets around other stars. So this was one area where there was a celestial event and the roles of astronomers and astrophysicists differed from roles of astrologers. Now another event happened about 4 years ago in 2017 with the total solar eclipse. This was also described in the media as the Great American Eclipse because the path of totality, where you could see the eclipse in its entirety, crossed a very large swath of the United States. So I was living in Colorado at the time. I was in grad school, and so I drove up to Wyoming to watch it, sat in horrific traffic on the way back down to Colorado from Wyoming, but it was really totally worth it. It was a magnificent sight. And here we're looking at a picture of totality. So we're seeing the moon completely blocking out the light from the sun. And you'll notice that we are still actually seeing some light here. So this is why you're not supposed to look at an eclipse without your glasses, because the sun doesn't completely disappear and even this residual light can hurt your eyeballs. Now again, in the lead up to the total solar eclipse, astrologers were assigning meaning to the eclipse and trying to make predictions about how it would impact human behavior. So we saw headlines about how the solar eclipse could affect your sign. We also heard from astrologers who said things like, eclipses are the most dramatic tools that the universe uses to affect change. Nobody likes change, but eclipses shake us out of our complacency and push us forward no matter if we're ready or not. And this feature in Time magazine actually opened by saying, the upcoming total solar eclipse will either wreak havoc on your life or herald waves of positive change. That is depending on who you are and which astrologer you ask. And so remember, we looked at constellations across the globe and we saw that the interpretations of the patterns in the sky differed broadly depending on which civilization whose records we were looking at. And the same holds true with astrologers' predictions as well. There's great variation in the interpretations and the predictions. Now, astronomers and astrophysicists instead used the total solar eclipse as an opportunity to study the solar corona, or the crown of the sun. And so this image was taken with a filter to extract particular wavelengths of light. And this may be a little bit hard to see, but they were able to detect these big loops, these plasma loops, and they were able to map structure and holes in the solar corona. Now this is really important and interesting work because these loops can sometimes turn into what are large coronal mass ejections. And as very catastrophically declared by this headline that I think was in Forbes, those coronal mass ejections can potentially cause a multi-trillion-dollar disaster. They could potentially wipe out all of our technology, leaving us kind of very much in the dark. And so it's really important for astronomers and astrophysicists to be able to study the sun so that we can understand, for example, the likelihood of an event like this happening, and maybe make some preparation so that we're ready if it does. And so here we're looking at a picture of the DKIST solar telescope, which is located on Haleakala in Maui, in Hawaii. And this beautiful picture here was the first light image that was taken from the DKIST telescope. And so this was one of the first pictures that was ever taken with this telescope. And this is a stunning image. So we can see all of these shapes that look like cells, and these are called convection cells. So the convection cells transport energy from the interior of the sun to its surface. And this is where those loops will originate. And this also could be where those coronal mass ejections might originate. So it's really important to map these convection cells, and there are lots of solar astronomers and astrophysicists who are doing this work. Now, I've shown you where astronomers and astrophysicists diverge from astrologers for just a couple of celestial events. But this happens all of the time. And so maybe with the next celestial event that comes up, you'll be able to kind of see what these differences are and understand how our jobs differ. Now, we've really just scratched the surface of the history of studying the night sky. And so I want to leave you with a few ways to think about this a little bit more if you choose. So one thing you could do is you could check out the work of cultural astronomers like Dr. Dorita Holbrook. Dr. Holbrook is a professor at the University of Western Cape in South Africa, and they work to understand astronomy in an anthropological context across the globe. And so they're really interested in seeing how the history of studying the night sky, and in particular civilization, has carried through to how people view astronomy and astrophysics today. So her work is really fascinating, and she has an excellent TED Talk that's available on YouTube that you can take a look at. And another thing that you can do is you can explore the constellations that were identified in other cultures using this free app called Stellarium. So you can download Stellarium onto your computer, or you can have it on your phone. And Stellarium has this really neat star lore tab. And if you click on the star lore tab, you'll see a whole menu of different constellation maps that you can pick. And so you can see what the constellations looked like for Aztec astronomers, for Chinese astronomers, Egyptian, Native American. You can look at a whole bunch of different cultures. I think there's about 60 in here. And if you were to click on one of these civilizations, you would see some information about how those patterns were interpreted and what constellations they used. And you'll also see references in here and some contact information for places where the archaeological work to understand how people interpreted the skies is still ongoing. So if that's something you're interested in, that could be a really neat way to get involved. So I'll leave you with the final answer to our big question. And that is that both astronomers and astrophysicists and astrologers make very detailed maps of the sky. So it's our job to know what is up in the night sky. And this allows us to determine when astronomical events might happen. So for example, eclipses and planetary conjunctions. And for astronomers and astrophysicists now, this also lets us determine when planets are going to be passing in front of their host stars, so exoplanets around other stars. Now, astrologers exclusively use those maps to make predictions about individual human behavior and maybe large-scale societal changes. So they really link the sky to human behavior. And astronomers and astrophysicists, we do not do that. So we use telescopes to observe the night sky and collect data. And we also use computer simulations to investigate the physics that shapes our universe. And so we are really studying astronomy and physics together to understand how the universe works. So that brings us to the end of our time together. Thank you so much for your attention, and I look forward to answering your questions.
Thank you. Thank you. That was wonderful. Nice little both historical lesson as well as modern interpretation of the differences and, well, paying respect to the common origins of studying the sky and how it diverges. I was particularly impressed when I was listening to you in going through the standard Tycho Brahe and Johannes Kepler and Copernicus, and how the sort of the divergence happened as we started to go from, I guess I sort of summarized it in my own head that, you know, the astronomy and the astrophysics went towards what are the causes of what we see, the changes in the sky, and the astrologers stayed with, well, what are the effects of it? You know, what do you think of that type summary?
Exactly. It was a very natural progression, moving towards physics and causes versus sticking with the effects.
Yeah. All right, I'm going to bring in Grant Justice. Grant has been monitoring our chat. There's been a bunch of stuff going on the chat. Grant, why don't you turn on your camera and join us? How are things tonight, Grant?
Hello. Yeah, we've had quite a lively chat tonight. It's been quite good. All right, so let me see what we got going on here. All right, so we'll start us off first with a good one. Is there an astronomy-based alternative to astrology birth signs that we can use?
That is a very excellent question. So the short answer is no. But that's because the birth signs were defined based on what astronomy was at the time. So the constellations that make up the zodiac that are used as birth signs are very real constellations. So you can look out at the night sky and you can see them. But the difference is that astronomers today don't use those as birth signs. They provide a map of the universe for where things are. So for example, I study star and planet formation. And so I think a lot about what we call the Taurus association. And so the Taurus constellation is important to me because it tells me where my targets are. Whereas I, as an astronomer, don't necessarily think about Taurus's meaning as a birth sign.
Right. I mean, in the scientific method, I mean, what the position of the sky on the day you were born doesn't have a, we're not looking for a human effect of that, right? And we're really, we're trying to look at the physics behind it. And so, as I think Carl Sagan put it once, the person delivering you at your birth has a stronger gravitational effect than any star in the night sky. So,
yes. Well, and you mentioned that the scientific method, Frank. So one place where this diverges is that as astronomers and astrophysicists, we are looking to make testable predictions.
exactly.
And so the thing that's difficult with birth signs is that you can't be born twice. And so that makes it difficult for that to be a testable prediction. And so that's where our work diverges from the astrologers.
Okay. All right, Grant, we have another question from online.
Yeah, absolutely. I'm going to throw this one in there while I'm looking for the other questions. A super important one from a viewer. How many marathons have you run?
Oh, I feel like I'm on the spot. I have run one. It went very badly. So I am actually really excited to run the marathon at the Baltimore Running Festival in October, and hopefully that goes better. But at the very least, it'll be a great way to kind of see the sights around Baltimore.
All right,
I will just note that we've had quite a history of runners at the Space Telescope Science Institute. When you actually get to go into the building, you can see the plaques that are up by the cafe of the runners and the team plaques that they won over the years. So.
Oh yes, I can't wait. There's a lively community in Slack, but it'll be great to meet everybody in person.
I'm sourcing a couple more questions here. You did a good job of answering most of them in your talk already, so that's a positive thing.
Okay.
So while you search, Grant, let me just mention that, because Nicole, I remember I was teaching a solar system class, researching Kepler's books and being surprised by just how much numerology actually was in it. Kepler was really, really looking for mathematical patterns, and he just went off the deep end in terms of the ways, the patterns. Have you looked at any of that?
I haven't read his books too carefully, but I've always been fascinated by how he came up with his laws. The one that we think about when we talk about planetary orbits is the relationship between the period, or how long it takes a planet to go around its star, and the distance between the planet and the star. And Kepler's rule that he discovered was that the square of the period, so this time squared, was proportional to the distance cubed. Now this is very weird, right? I don't like thinking about things that are squared and cubed in my head when I know what the math is. And so I can only imagine the rabbit holes that he went down, to identify these patterns. It was really, really remarkable science.
Right. And he went down a lot of rabbit holes that didn't lead anywhere,
Yes.
which is what I found in my research. And it was like, okay, but that to me, that marked really the divergence from getting to the physical explanations and trying to just come up with these empirical laws that fit these things. So it was an interesting time in the history of astronomy.
And it was really clear that, his background as a mathematician was really what allowed him to find this pattern and identify this connection. So there's definitely a lot of overlap between astronomy and astrophysics and with physics and math. And now chemistry too, as we're finding.
Well, I mean,
very cool.
I'm sure you get a lot of kids asking you, well, what do I need to study to become an astronomer? And really, you need to have your math before you can have your physics, and you need to have your physics before you can do your astronomy. So it's really this layer cake of building up to get to these things.
And it all comes together.
Grant, we've been vamping. Go ahead.
Sure. I actually like this one. So, having given your talk and done the research on it, what would you consider the benefit of astrology?
That's also a very good question. I don't think there's anything bad about people feeling good. And so people across the world really put a lot of faith in astrologers to make predictions that might dictate the course of their lives. And I think that can be very dangerous, right? It can be a dangerous thing to give somebody else control over your life. But it's very clear that sometimes those predictions can give people a sense of peace and maybe some security in having a path that's charted out. And I don't think there's anything wrong with that. It's not what I do as an astronomer, but I think that's something that's positive. You can never go wrong with people feeling good.
I would also say that I have a number of friends who just treat it as entertainment. Okay, it's they don't take it too seriously, but they check their horoscope sometimes in terms of treating it as an entertainment device. For that, and there's nothing. We got plenty of ways to entertain ourselves.
But very important to keep the distinction.
Exactly. Yes.
And that's where the Hollywood and other forms of entertainment blur the lines between them. Unfortunately.
Exactly. Yeah.
Agreed. The chat has just been backing up most of the things that you've said already. We really don't have too terribly many questions so far. So,
okay.
Let
me look at some of my notes here. Well, I mean, one of the things there was a question about the zodiacal light. You mentioned the constellations, the constellations of the zodiac. Can you talk about a zodiacal light, and does this have any relevance to astrology or the constellations of the zodiac?
So the zodiacal light is a little bit different. As far as I know, the astrology does not incorporate the zodiacal light. And so this is light that's kind of scattered off of very small dust grains in the solar system. And it's very, very hard to see. So I personally have never seen it. You have to go somewhere where the skies are very, very dark. But it is not directly connected to the constellations in any way. I'm actually not sure of the origin of the name zodiacal dust.
My guess was that, it's in the plane of the ecliptic, basically, right?
Yes.
And the constellations of the zodiac are going to be, in the plane of the ecliptic. So that the only place you're going to see the zodiacal light is along the ecliptic,
right.
In the constellations of the zodiac. Was my guess, understanding. I haven't studied the zodiacal light myself.
So it's quite possible that in early times, it was easier to see the zodiacal light without the pollution that we have from our cities now. But as far as I know, it is not incorporated in astrology.
I mean, when I was researching the story that we did on the Great Comet today, I was like, look at all these great comets that occurred. Oh yeah, this was before we had the light bulb, of course. They could be great comets because you could actually see them in the dark night skies.
Exactly, yeah. It really made a difference.
Okay, Grant, do we have anything else on the chat?
No, we're good on the chat, so.
Fantastic. Well, thank you very much, Nicole. That was a wonderful talk. Next month, we will have Todd Lauer talking about how dark is the night sky. Thank you all for joining us today, and we will see you next time.